Welcome everyone to Plastics Frontiers webinar series. The Plastics Frontiers webinar series was developed by the collaboration between the Royal Australian Chemical Institute, Society of Plastics Engineers Australia New Zealand and Society of Chemical Industry. We are thankful for the sponsorships from BSF Australia, Reckitt Benckiser, Qenos and Foundry Intellectual Property. For any concerns, please reach out to RACI. We are also thankful to the organising committee, Gary Bowman, Chair of RACI Industrial Chemistry and Dr. Yvonne Ma, Han Michel, President of the Society of Plastics Engineers Australia New Zealand and Dr. Steve Petanakis, Jenny Sharwood, OAM of the Victorian Education Committee for RACI and Dr. Richard Tweets, also Chair of Society of Chemical Industry. The purpose of the series is to highlight the continually evolving role and important contributions of plastics in society, some key societal and environmental issues faced by the plastics industry, and how the industry is rising to these challenges with new innovations and practices. With our backgrounds in education, industry, and academia, we are reaching out to as many sectors ranging from secondary chemistry teachers and students to researchers and innovators in industry and in universities. We hope you enjoy this series. Thank you for watching.
Right, good evening. Good evening, everyone. Welcome to our final webinar in the series, which is called The Future and the Circular Economy. And I'd like to firstly acknowledge our founding members for the series, the SCI, RACI and SPE, for putting on this series of webinars. So thanks to Han and Yvonne, and also I'd like to kindly thank our sponsors. Without such generosity, these sorts of events would not be possible. So Reckitt Benckiser, BASF, Foundry and Qenos. So thanks to all our sponsors. So we have a fantastic lineup of speakers this evening for the future and the circular economy, a timely subject nationally at the moment with all the development that's happening in this space with various industry partners and organisations. Our first speaker this evening is Helen Lewis, and I will introduce her with her bio. Just bear with me one sec. So Dr. Helen Lewis provides research and strategic advice to a range of industry and government clients on product stewardship and packaging sustainability. She's an adjunct professor with the Institute for Sustainable Futures at the University of Technology, Sydney, and a consultant to the Australian Packaging Covenant Organisation. She's been working in this field for over 30 years, having started as environmental manager with the Plastics Industry Association in 1990, and then taking up various roles in government and academia before starting her consulting business. Helen holds a PhD in product stewardship and is a fellow of the Australian Institute of Packaging. Welcome, Helen, and thank you.
Thanks, Steve. Just let me share my screen. Here we go. Okay, good evening, everyone. Thanks very much for having me this evening. It's a great pleasure to be here. So today or tonight, I'm really talking on behalf of APCO. I'm going to talk about how we're tracking towards the 2025 national packaging targets, particularly for plastics, because that's the topic for this evening. Some of the gaps and some of the ways we could maybe ramp up the action to try to meet them. Unfortunately, I'm not going to be able to share much data from the 2019-20 survey, but I am going to share some of the unpublished data on reprocessing projections to 2024-25, which is very relevant to the topic today and some of the initiatives that are underway. I am particularly keen to get feedback from you as well in the Q&A or the chat box. But first, I thought I'd start with a quick flashback, a reminder of how far we've come and how old I'm getting. I first got involved in this area back in the early 90s. I hate to say that 30 years number, which is a bit scary, but this was when we were starting to look at how to add plastics to curbside, and this was a trial that I was involved in back at the Plastics Industry Association days, adding plastics to crates, which were very modern at that time. Of course, now we've got plastics recycling across the country through curbside. I then joined RMIT Centre for Design, and we were doing a lot of work on eco-design. And this is a picture of me taking apart a Cambrook toaster for a life cycle assessment. You'll notice that I've got some very sophisticated equipment there, including a hammer. But of course, now eco-design is mainstream. It wasn't back then. It was quite, I guess, leading edge. Now it's pretty mainstream. And I should mention that back then, when I was working at RMIT, our plastics consultant was none other than Professor Ed Cozier, who is continuing to do great things. So what are we working towards? These are the 4 national packaging targets. 100% of packaging to be reusable, recyclable or compostable by 2025. 70% of plastic packaging recycled or composted. Phasing out problematic and unnecessary single-use plastic packaging, and 50% average recycled content across all packaging. So how are we going? We're part of the way in, and it's only a few years to 2025. Just to start, plastics by weight. So it's about 1 million tonnes of plastic packaging. This is just packaging placed on the market back in 2018-19, out of around 6 million tonnes in total. So it's a significant proportion, which is still roughly the same by the look of it for 2019-20. If we look at recycled content, the targets are there on the right-hand column, 50% for packaging, but 20% for plastics. And we've called out a couple of specific targets there, 30% for PET, 20% for HD, 20% for PP, and 10% for flexibles, which is probably a heroic goal at the moment. But if you look at how we're tracking, we're only at around 4% for packaging overall, higher for PET, of course. If we look at recovery rates, 2018-19, about 50% of all packaging recovered, but highlighted there is the 18% for plastics, plus or minus, a margin of error. And we're aiming for 70%. So we still have a big way to go. The rates for rigid are better. About 28% of rigid plastic packaging was recovered in that year, and even higher for PET at around 41%, 25% for HDPE, which is, nowhere near good enough for a material that's very recyclable. Polypropylene, only 17%. So even on rigids, we're losing a lot of material at the point of collection, given that most curbside bins accept all rigid plastic packaging. If we look at recyclability, the target is 100% of packaging to be reusable, recyclable or compostable by 2025. We're at approximately 89% for all packaging, but only 66% for plastic packaging having good recyclability. And I've just put that table there to show how APCO try to estimate the percentage. And it's based on something having access to a collection facility, around 80% of the population able to recycle it, that it can go through the MRF effectively, and that there's a well-established market. And we also publish data on poor recyclability and not recyclable. And this is, of course, important to track how we're going in terms of design for recycling in particular. So what do we need to do to meet the targets, given that we've got significant gaps in a few areas, both in the recycling target to get to the 70%, the recycled content target to get to 20 or 30%, and the recyclability target to get to the 100%. So these are some of the gaps. I won't go through all of this, but this is something that we're trying to understand at the moment. Obviously, there's a lot of work being done already, but thinking about between now and 2025, what do we need to do? So if we look at PET, look, mostly very recyclable. We know there are types of packaging that are not recyclable, like opaque PET. We know that some of those packaging types aren't as recyclable, like thermoform trays and clamshells and so on, not always sorted at the MRF, sometimes thrown away at the recycling plant. The soft plastic, the coloured PET. So there are quite a few areas where we can improve design. Recycled content, there has been an issue with access to food grade, and I'm sure we're going to hear about this from PACT. We're on track to be able to meet that target for PET. But we are, as I said, getting high losses from households. If we're recovering about 40%, that's just not good enough for PET when there's such strong demand. Recycling away from home is more limited, and as I said, thermoforms. If we look at HD, there are certain issues that can be addressed through design, and there's a lot of action happening there. Companies that are trying to use more food grade, there's issues with availability, particularly food grade to go back into things like dairy, milk bottles. Once again, we're seeing quite high losses from households as well as from B2B packaging. PVC, a whole range of issues, both for rigids, which are not generally classified as recyclable today through curbside. Soft plastics, not recyclable. There's a lot of work to phase out PVC and PVDC. Technical challenges, getting it back into soft plastics, of course, but on the recovery end, not accepted through most MRFs, not accepted through Red Cycle. LDPE, there are issues with design for some of the rigids. For soft plastics, it's particularly hard to get recycled content back into it unless we do, or until we get access to more chemical recycling facilities. And one of the big issues in terms of recovery, that there's a lot of work happening in this area, it's the limited end markets that are the constraint at the moment. They really don't justify increasing collection, although that will happen. PP, highly recyclable, not always sorted and recovered through MRFs. There are issues with design there as well, but there is a trend away from things like polystyrene to polypropylene. So we're expecting to see more of that on the market. There are issues to be addressed at the MRF in terms of recovery, because we know that there are good markets and there's work happening there at the MRF end as well. Polystyrene, there is a trend away from polystyrene. It's one of the ones that's counted as not recoverable. It's technically recyclable, but not accepted through most of the MRFs or not sorted. And EPS, of course, limited collection and recycling facilities. There are drop-off facilities and collection facilities for B2B, but they're limited, and households can't recycle their EPS without a fair bit of work at the moment. So if we think about getting to 2025, what are the gaps and how do we try to fill them? I'm just going to go through a couple of scenarios. One of them is business as usual, like what do we know is on the horizon now? And then what could a scenario look like that might get us to the targets? If we look at BAU, consumption is still going up slightly. It seems to be leveling off per capita, but it's still going up. There's a lot of work to phase out PVC, EPS, polystyrene, lightweight shopping bags, and so on. And that's through both the APCO action plan for single-use plastics, the National Plastics Plan, and a lot of state jurisdictions, of course. A lot of corporates have got targets to design for recycling. The Australasian recycling label is being rolled out very rapidly onto products. And we've got a target now, a national target of the ARL being on 80% of supermarket products. I think it's by 2023. If we look at collection and recycling, there's a ban on exports of mixed polymers, baled or processed by next year. On a positive note, we're seeing CDS expanding to Tasmania and Victoria, which will produce clean streams of PET and some coloured HDPE. We're looking at doubling the local reprocessing capacity, and I'll show you some figures on that shortly. From what I hear, and you guys, a lot of you will know more about this than me, but we may have one small recycling plant, a chemical recycling plant by then, or that maybe that's a bit optimistic. End markets, we're seeing a lot of corporates announcing targets for post-consumer recycled content. So there is strong demand. We're on track to meet the PET target, might be a little bit more problematic for some of the others. And just a few things, obviously there's lots of case studies I could use to illustrate this, but just reading today, Tip Top eliminating their polystyrene bread tags, replacing it with cardboard. Colgate's new tube, they've redesigned it so it's now 90% PE and recyclable through curbside. Melbourne Coffee and their recyclable bag. There's a lot of companies working to meet the CFlex guidelines for recyclability for soft plastics. And a lot of brands announcing targets for post-consumer recycled content. And Unilever's just one of those. And it's great to see their advertising, mainstream advertising, that they're using recycled. So what could a scenario look like with some more step changes? And this is the work that's happening at the moment, where we think, well, what are the gaps? What are the interventions? What else could we do to meet the targets? So here's just a few quick options, or obviously these are things that are being looked at now. Reduction in consumption. What can we do? Is it through efficiency? Is it through reuse? Design for recycling, absolutely essential that we get there, and there's a lot of work happening to do that. And the ARL on all packaging, including B2B. If we look at collection and recycling, can we expand curbside to include soft plastics? There's work happening up on the central coast of New South Wales to trial this through Curbcycle. It may not be accepted by all councils, but I think some will take it up. Product stewardship schemes are being developed for quite a few problematic items, soft plastics being one through the AFGC, but also coffee pods, cosmetic packaging, agricultural packaging, and so on. So we are going to see a lot more product stewardship schemes being developed to provide some of the underpinning finance and work to make this happen. We do need to see increased collection from commerce and industry. We do need to see increased collection from households. So how can we boost the behaviour of consumers to recycle the materials that are already recyclable, like PET bottles, like milk bottles? And we probably need 4 times the current reprocessing capacity. End markets, there is some work happening on a brand owner pledge program on committing with companies committing to use a lot more post-consumer recycled, we've got at least 4 or 5 feasibility plans, feasibility studies underway to look at advanced recycling or chemical recycling, but this is essential, particularly to get closed loop recycling back into soft plastics in particular, and some other types of food grade. And we are going to need a significant increase in procurement of recycled products, not just from industry, but also from government. Now, I mentioned the data that we're getting from on reprocessing capacity. As part of the 2019-20 survey, the consultants asked reprocessors about their capacity utilisation, and they also asked them about their plans to expand over the next 5 to 6 years. And it was quite interesting to see the predictions were, or the projections were, that capacity would increase from around 160,000 tonnes in 2019-20 up to about 400,000 tonnes by 2024-25. So that's quite a significant expansion. If you look at by material, there's some pretty significant differences. We've got PET expanding quite significantly from about 55,000 tonnes, with all of the announcements that have been made, which are reflected in this projection, going up to around 123 by 2024-25. A very significant projection for HD, going from 60 to around 135. Surprisingly, quite a big increase for LDPE, up to about 53, and polypropylene as well. So we're seeing very high projections. It would get us to around 400,000 tonnes. If we look at the projections for placed on market, that's also expected to go up. So it should get us to around 30 to 35% recycling rate, which is still not 70. Now we're going to hear from PACT after this, but from the tracking that we've been doing on announcements through all the grants, the Recycling Modernisation Fund, and so on, we've got a lot of announcements coming. These are just two from New South Wales with Astron Sustainability and the PACT Asahi plant down at Albury. In WA, there's an announcement from PACT and Cleanaway of a new plant around 17,000 tonnes. Victoria, there's a lot of action happening down there. Advanced Circular Polymers improving their processes to produce more higher quality flake. The PACT and Cleanaway facility at Laverton, and a couple of plants announced in Tasmania. So we're seeing a lot of announcements coming through. Before I finish up and hand over to the next speaker, I was also just going to mention ANZPAC, because I know that a lot of you are very passionate about plastics and plastics recycling. The ANZPAC, the Australia, New Zealand, Pacific Plastic Pact was launched earlier this year. And it's one of about 11 pacts that have now been launched in conjunction with the Ellen MacArthur Foundation. And so this is very exciting to be part of a global network. There's about, I think, between 80 and 90 members have now joined up to work with EMF. And just very briefly, some of the things that the ANZPAC members are going to be working on: a regional roadmap. I think there's about 6 organisations from across the Pacific region, as well as New Zealand and Australia. So it's quite an interesting group. They're going to be developing some working groups, working on some practical projects. There are some specific targets for the region. So it's quite interesting for the soft plastics area in particular. They're starting to work on, well, we know what the challenges are for Australia. Where are they overlapping with issues in New Zealand? And how is it quite different in the Pacific, in Vanuatu, in Fiji, and so on? So it's going to be a very interesting process to look at how we can share knowledge and do things together in the region. If any of you are members, you can become a member, of course, and there's an annual fee for that, but you can also become a supporter at no charge. So I just thought I'd mention that for those of you that have got a lot of experience and knowledge in this area. If you're interested, just let us know. And that's all from me. And yeah, keen to get questions or feedback later on. Thank you.
Thank you, Helen. Thank you for a very insightful presentation. Certainly moving forward towards those 2025 targets, there's a lot of challenge, but certainly a lot of opportunity. So thank you so much. Moving on, gives me great pleasure to present our next speaker, Professor Cozier. So just give me 1 minute. So Edward Cozier has been active as an innovator in polymer technology for the past 35 years, both within universities and recycling enterprises. He's an honorary professor at Brunel University, UK, and a fellow of the Society of Plastics Engineers, as well as a fellow of the Institute of Materials, Metal and Mining, as well as fellow Royal Society of the Arts. He recently received the Prince Philip Medal for Plastics in the Service of Man from the Institute of Materials, Metals and Mining. He was the Associate Professor and Director of RMIT's Polymer Technology Centre, that's going back a few years, before moving to the business world to design and operate Australia's first mixed plastics recycling plant for Visy Industries in 1997. Many plants have followed internationally, including the latest in Australia for Cleanaway Pact. Professor Cozier specialises in design of advanced recycling plastics installations, food grade from post-consumer plastics such as PET, HDPE and polyprop, provides support to global companies in creating high-performance circular plastics products, mixed plastics recycling, minimising carbon footprint of packaging and bioplastics packaging. Welcome, Professor Cozier.
Okay, thank you, Steve, and thank you for that kind introduction. Just call me Ed, please. And thank you, Helen, for setting the scene, bringing us back to the days of RMIT. And you might remember our first publication was called Design for Plastics Recycling with Chris Ryan and John Goutsakis as our co-authors. And that was quite some time ago. We had lots of fun doing that. And I can remember you being an expert at the hammer. Okay. My talk is about what does the future look like for plastics. This is a bit of a background slide about Nextech, but I'll skip over that because we've been introduced. We've had the scene set by the state and federal government encouraging the establishment of better recycling facilities right across Australia because the bans on exports have been announced, and of course we need to do something about improving the way we handle the post-consumer materials that we've got. The bans will supposedly shift us to processing something like 77,000 tonnes of materials that are currently destined for exports, but a bit more about that later. Something that's also quite important is that in February, 2 of the refineries that we've got in Australia were announced as if they were going to be closed, leaving only 2 behind, one in Geelong, of course, and one in Brisbane, which means that locally produced hydrocarbons and fuels are going to be limited to those facilities. And this is important when we think about chemical recycling. Most of the plastics that are used in Australia are imported. And out of the 3 million tonnes of plastics we use a year, something like just under 1 million are locally produced. So we largely import 2/3 of our plastics materials. And something that's even more concerning to me, rather than the amount that we recycle, is the amount of plastics that we landfill. We landfill something like 820,000 tonnes of plastics. That's a really big number. And we lose the value of at least $250 million per year. And we lose the opportunity to save something like 500,000 tonnes of CO2 equivalents. And of course, we do recycle the 125,000 tonnes of plastics. They're the numbers that we've got recorded. And, you know, my focus here is how do we move from a situation where we don't have a well-developed economy to where we actually are doing something significant. And I call this moving from indifference to making a difference, because I think in the last 20 years, we've been watching, we've been studying, we haven't actually put our minds to doing a lot more about the circular economy. And I think we are now very focused on creating a circular economy. And this is where I think companies are moving towards making a major difference. So we've got a need to create greater MRF resources and recycling resources. Great to hear Helen's projections about where we might be going. They would certainly be completely necessary, if not bigger. And clearly, we need recycled content in packaging to create the markets for the materials we recover and recycle. This actually has big implications about the quality of those recycled materials. And I do note that some of the recycled content that's being used in Australian packaging is being imported. Now that really doesn't make sense. If we're generating waste plastics here in Australia, we should be recycling those materials, not importing recycled content from overseas. And in the innovation area, we have lots of things that we need to resolve. And things like sorting food grade from non-food grade. This is a precursor step to implementing food grade recycled plastics. With 800,000 tonnes of materials going to landfill, we need to become very good at recovering those plastics from what we call a waste stream right now. And when we start to recycle, there are going to be chemical effects on the polymers, and we need to be able to maintain high performance in those plastics as we're closing the loop on our existing and new applications. What sort of things can we do better? And here I'm saying that what we have is we need a shared vision in the chemical waste and the recycling industry associations so that we can have better buy-in from the brands and converters. And I know everyone's working towards this, but I was astounded to see that on Chemistry Australia, there is no vision for a circular economy. And of course, this vision has to be shared by all groups if we're going to make a difference to the way we recycle materials. Common targets, common action, and supporting each other in hitting those targets. We need big recycling operations to make high quality recycled plastics in every major population centre, so we don't have the tyranny of distance adding to the carbon footprint of recyclates as they go into new applications. And we need research that focuses on the circular economy. When I was looking for research in Australian universities that actually supports the recycling industry, I find very little. We find lots to support the polymerization side, but really the circular economy is focused in quite different areas. We don't have large petrochemical operations that actually could support chemical recycling. And this is actually going to be quite important for the future, especially for difficult to recycle materials. And if we don't have these large operations, then what will this mean if we're waiting for chemical recycling as an option? I think to me, it means we have to get on with mechanical recycling because it's available. We're also missing the infrastructure for composting biodegradable plastics. And if those materials, if those facilities aren't available, then it doesn't make a lot of sense to put lots of research into compostable materials as alternatives to the plastics that we currently have. We don't have any bans on oxo-degradable materials. In Europe, these are already banned. When I'm offered plastic bags in my community, they're all full of degradable additives, which is extraordinary because these have an impact on long-term properties and recycling. And I think one of the things that's missing, which I think will come, is we don't have a government tax on packaging that occurs without recycled content. In Europe, these taxes are being applied and they're having a major stimulus to the activities around Europe, especially in investment and in the direction of brand owners and retailers. Just to put Australia into the picture, we make 0.36% of the world's packaging, of world's plastics compared to the rest. And as we might imagine, most of the world's packaging materials are made in Asia, 51%, Europe's only 16%, and North America about 19%. So what we do in Australia is important for us, but really the problems of plastics globally are even bigger, and they're located outside of Australia. Where are we heading with plastics? If we go down the road of business as usual, we will have quite serious consequences, and I think we've all heard about these in other areas. And there is an excellent report, Breaking the Plastics Wave, by Pew Foundation Trust, which maps out what will happen. In essence, we'll end up with something like nearly 30 million tonnes of plastics going to oceans. We'll be producing something like 400 million tonnes per annum of plastics. We'll have high costs to government and business to cope with these scenarios, and we'll have very large CO2 emissions. That's business as usual. And I won't linger on this point because it's important to think about what is it that we can do to mitigate this whole situation. Just recently, we had Earth Overshoot Day. You probably will have heard of it. It's the day when we've used up the resources that the planet can sustainably maintain. From now on till the end of the year, we're living off the future. And so this emphasizes the need for circularity and the need to conserve resources. In Europe, they've promoted the European Green Deal, where they're going to spend something like 100 billion in research and development to achieve climate neutrality by 250 by inventing the new technologies that they'll use. As of the July 2021, so just recently, they have phased out single-use plastic. So that those materials will become non-marketable in Europe, and they'll have to be marked that way. They have very clear targets to reduce waste from their current 500 kilos per head. And their focus is on both packaging circularity and carbon footprint reduction. These are things that we need to adopt as well. And again, there are many important benefits from these targets that they've set for the whole community. This figure comes from the Pew Foundation Trust, the figure on the right, which shows what will happen if we stay on business as usual. In other words, going from our current figures of around 350 million tonnes a year, or a million tonnes per day, we would be at 400 million tonnes by 2040. And there are a series of changes that we can make to change. In this case, the target was, what can we do about plastics going to oceans? So the projections are that we could reduce the growth in plastics production by nearly 1/3. And we could substitute plastics with other materials, including paper and other products. Design for recycling is a big factor. And of course, expanding waste collection, increasing mechanical recycling, and developing plastic to plastic conversion techniques, both chemical and others. And then also building facilities that will safely dispose of materials that are not easily recycled. And of course, the elimination of exporting of plastics materials to countries that have poor infrastructure. If we do all these things, we can have a series of benefits. These are the projections with maximum intervention. So instead of having 30 million tonnes of plastics going to oceans, it can be reduced to 5, which is a great change, but we still have a problem there. And of course, this will also bring benefits of increasing the number of people working in the recycling industries. There'll be savings of 1.6 billion tonnes of greenhouse gases, and reduced cost to government and reduced cost to business. And so all of this can be done with existing technology. We just have to have the application and the direction to do it. Right now in Europe and the United Kingdom and Europe, we're seeing the implementation of plastics and producer responsibility. And this is in the face of the current feelings of communities to do something about the global plastics crisis. Many companies are switching their packaging away from plastics, even though plastics are often the lowest carbon footprint product. And this trend will continue, and we'll see it daily. And in some cases, it's a great thing. In other cases, it doesn't make sense. We're not necessarily using science. And the whole process about recycling and creating a circular community, a circular economy for plastics, is creating a very large demand for high quality post-consumer recycled plastics. Right now, it costs far more to buy high quality recycled PET than it does to buy virgin PET. And the same is true for high density polyethylene, and will be true for polypropylene as well. If we have a look at some of the things that are stopping the circular economy, part of it is the initial concept of the circular economy, where we use waste to make new materials, which is the big challenge. But here I'm hesitating to say, let's not call it waste, but a resource. And of course, we need to put it back into products, and that is ideally the same product. And this tells us how we should direct the recycling effort. Obviously, designs have to be recycling friendly. Formulations have to withstand multiple passes through heat cycles and oxidation. And of course, if you print and color materials, you pigment them forever, and you need to be able to remove those pigments. And of course, not all packaging is made from monomaterials, and that limits their recyclability. And of course, we have the challenge of food grade recycling. To be truly circular, we have to have this happening across the range of materials. And we can actually recover far more materials than we currently do. That's one of the bigger challenges that we currently have. And if we have a look at what we can achieve, if we look at the maximum recovery rate for taking into account collection, sorting and recycling, typically we can recover something like 60% of those materials for recycling. This is a sensible, practical limit, which tells us what we should be heading for, because many companies want to go for 100% recycled content, which globally actually is not highly achievable. So if we look at what we can recycle, it is, and here we're focusing on the big ones, the PET, PP and HDPE. As Helen mentioned, films are challenging. Very few post-consumer films are being recycled right now. There are some techniques where we can actually recycle these materials back to food grade, but they're exploratory. Polypropylene, now we can actually recycle these back to food grade materials. And these are typically in pots, tubs and trays, not the traditional bottles. PET, we can recycle back to food grade. Thermoforms, we have a big question mark because many bottles are recycled back into thermoforms, but we see little recycling of thermoforms, and the process technology has been questioned in Europe as to whether thermoforms will be suitable for food grade. HDPE is another important one. We can recycle back to food grade, and of course it is happening here in Australia as well. In Europe, what is the situation there? Can we learn something from what they're doing? There, they are recycling far more than they're landfilling. So over 9.4 million tonnes compared to 7.2 million tonnes going to waste to energy. So what we have is quite a different situation in Australia. So there, the focus has been on collection and recycling. And this is a demonstration that this can be done. However, we should note that waste to energy is a big part of the processing of post-consumer materials in Europe. But this is now being questioned because we have CO2 targets, and now all of the energy converters are being asked to remove plastics from the waste to energy process. So a new challenge for them. So back to Australia and say, what are we doing? The recycling rates, thank you, Helen, for covering those. The recycling rates for PET are quite respectable, and they'll continue to improve. HDPE is at 25%. This is for rigid plastics. And polypropylene, it's at 17%. These are not necessarily circular processes, because very often they're going from packaging to things like pipe, or packaging and to materials handling, but we haven't developed the circular economy in these areas just yet. The big challenge, of course, is in flexibles, in linear low density and low density, where most of the recycled materials come from post-industrial sources. And so we're not really getting the focus on recycling into a circular economy. We still have a spiral or a linear economy. And my comment here is that the tonnages of materials that are collected don't necessarily mean we're recycling all of those materials here. Much of that is exported with the losses of value and energy. And so, you know, I think that our focus needs to be on the 82% of plastics that are landfilled, because that is a huge amount of material that we're currently ignoring as a huge resource, given that we import most of our plastics for packaging from overseas. So in the future, and in fact in the present, we should have brand owners bringing their products back, bring their plastics back into their products, closing the loop, including recycled content, accepting that we may have color variation, and perhaps also reducing the amount of pigmentation so we get clear materials into finished products. And of course, this brings to question how we design materials. In some cases, we use resins with no pigments, which makes these highly prized and highly recycled. But when we do have pigments, we actually need to think about that very carefully, because it limits the next cycle application of these materials. And even labels and the inks and the adhesives used to fix the labels can have a really profound effect on recycling. This is an area that really deserves a lot of attention, especially when we start to close the loop on plastics, taking through that loop many times. There are many things happening globally about how to go from post-consumer to the supermarket shelf. And this is one situation where a product can actually be sleeved and it can be put on the shelf, and it will look virtually like its original virgin counterpart just by applying a sleeve. Now, this really is a very simple technology which allows the use of grey post-consumer materials. And in many areas, we are already seeing good examples of highly evolved designs for the recycling of packaging. Again, this is not difficult. This is just good thinking and good design, and it makes recycling very simple. Helen mentioned polypropylene. This is probably the next frontier, because polypropylene typically does not come up as a bottle, and for many years it's been exported in the mixed plastics fraction, yet it's very widely used. And this is the beginning of the journey for polypropylene to get recycled back into circular products. And because polypropylene is very widely used in food, we very much need a food-to-food recycling technology. In the collection, we need to be far more streamlined and far more effective in collecting the materials. We still have on the market materials that look like, for example, PET. We have PLA on the market, which is not composted. It just simply goes to landfill, where it'll sit for a long time. We don't even have the opportunity to recycle those materials or to recover them. And in this case, we really need to look at streamlined collection systems for all the packaging materials. This actually comes back to the point of how do we close the loop? We actually then need to define specifications for resins that are very consistent, free of contamination, free of odor, and able to be used back into original applications. And this is really where the focus is in Europe. To put a recycled material on the market, you have to meet very stringent contamination, freedom from contamination requirements. And also you need to demonstrate stability of production. And so recycled resins are becoming, like virgin materials, completely reliable and suitable for production. I don't need to say too much about mechanical recycling, and I'm going to just skip through a couple of these slides, but just to show that mechanical recycling is quite readily doable. We can build plants literally anywhere we collect plastics. We can build plants and recycle materials very simply. And I say this in contrast to chemical recycling, which will require multi-million investments, which will possibly inhibit or delay issues of recycling. We know that we could take materials back to food grade. One area we're working on is the recycling of polypropylene in the Next Loop program, which has attracted a lot of support and attention, being run in Europe and in Australia. Just a quick word on chemical recycling. Often this is a depolymerization for PET. If we depolymerize PET, which many people are proposing, we need to feed back the components back into a polymerization process. In Australia, we don't polymerize PET, so it's hard to see depolymerization and repolymerization happening here. In chemical recycling, we've made comments earlier, we need an associated collection system and a system for pyrolyzing material back into an oil, which can then be cracked. This is unlikely to happen in Australia as well, given our situation. Home composting of packaging. this is a PHBV tray made from basically sugars. And when it was home composted, it took something like nearly a year to fall into the sort of fragments that would be considered compostable. Home composting is not going to be a solution for the packaging requirements that we have for food manufacturers, nor for the use of a backyard as a waste disposal system. It's just simply not going to work. So in terms of where we're heading, we have to recover and reuse materials. The circular economy is the direction that offers the most immediate and effective way forward for the future for plastics. Obviously, we have to prevent ocean plastics. And that really means we have to catch plastics on land as opposed to trying to fish them from the sea. And we need to have change based on science and not on retail and marketing. Otherwise, we end up with higher carbon footprints than we expect. And we very much need large-scale recycling operations. So heartening to hear of those new implementations that are being planned for Australia. And I believe we also need resin companies and brand owners to have a stake in recycling operations. And it's great to see the Asahi Pact and Cleanaway operation where we have a mutual stake in all of those in those recycling operations. At the very bottom of this slide, I've got something which popped up on my screen today about VisiGlass, increasing the recycled content of glass bottles from 33 to 43% in just 10 months. Wouldn't that be a great story for the plastics industry if we could do the same thing to boost our recycling rate by that quantum? So my last slide is about the NASA Mars mission. And we can see the little circle or the circle showing the small helicopter. This is amazing technology. So if we can achieve that, then we can also achieve a circular economy for plastics. Thank you very much. And I'll stop my share. Thank you. I look forward to questions.
Thank you, Professor Cozier. That was a very insightful and educational presentation. I agree with you wholeheartedly regarding your comment around the science. Unfortunately, a lot of the decision making is based on misconception in the plastics industry through various channels and is not driven by the science. So I agree with you wholeheartedly on that one. Thank you very much. We've got a few questions, but I'll leave them to the Q&A session. So we'll move on to our next speaker. It gives me great pleasure to introduce my fellow PACT employee, Paul Miskell. Paul holds an Associate Diploma in Mechanical Engineering. He has 25 years experience in running various manufacturing businesses in Australia and overseas. He has worked previously in the underground coal mining industry between 1995 and 2002. He's also worked and lived in the US in 2001, 2002. Paul joined Astron Plastics Recycling at the Curran Ingleburn site as the site manager from 2004 to 2007. For 4 years, he was general manager running a specialist slip-forming concrete construction company between 2007 and 2011. He rejoined Astron Plastics Recycling 2011 as the Australian business manager. And in mid-2011, PACT Group acquired Astron Recycling. He formally assumed the role of General Manager for Operations PACT Recycling in 2013 and is currently the lead technical operational lead for the joint venture projects involving the Albury and soon to be built recycling plant in Laverton. Paul's an avid swimmer who is desperately missing the pool due to the COVID lockdown in Sydney. And he's married with 2 adult children. Welcome, Paul.
Thanks very much, Steve, and thanks for the opportunity to give a brief but hopefully informative presentation on a little bit about PACT. Share my screen here quickly and get that out of there. And also talk a little bit about what we're doing with our joint venture businesses. So I thought, to start things off, one of the neat things with living in the modern age is you have lots of modern toys that you can play around with. And our construction company that's, and what we're looking at here on screen is our latest joint venture business in Albury, which will be our PET facility. And our construction company, Joss, have one of their guys who is a part-time drone operator. And at the beginning of each month, he takes the opportunity to do a 360-degree flight around the plant, and we share it on a SharePoint. So what I'll do, it just goes for a minute or so. So I'll start it, and whilst it's doing its thing, I can
share your screen, Paul.
Oh, not sharing it. Oh goodness! Start.
Not yet, Paul. Now
how's
good.
that? Sorry,
that's better. All good.
Got to press the right button. So as this does a little bit of a circumvent, I can talk a little bit about it. So we're currently in Albury here with our latest joint venture business with Asahi and Cleanaway. And this facility is being built in the Nexus estate, which is about 10 minutes north of the Albury CBD. Sadly, it looks beautiful now, the surrounding landscape, but give it a couple of years and it'll be filled with industry. The factory itself sits on 25,000 square metres of land. It was originally 20,000 square metres, and this back portion here where you can see some stuff stored, we pinched another 5,000 square metres just because we could, and we felt it necessary for any future expansion. The factory itself is about 8,500 square metres under roof, and we will have on that roof surface about 300 kilowatts of solar power generation for the facility to not operate completely on, but certainly give it a helping hand when it's functioning. And there's about 100,000 litres of rainwater storage that we'll be collecting from the roof. But it's an impressive site, and very, very pleased and thankful that we chose some really good stakeholders in getting it to where it is at this point in time. And I'd like to call out in particular TMX. TMX is a consulting firm that are looking after the project management. They initiated Joss Construction, who are building the facility for us. And in association with those guys, we've got Babbage and our friends at Nextech, who have been heavily involved in vetting the OEMs, designing the plant as it is now being built, and also being the voice of reason and some technical background and validation on how it was going to take shape. And it started in angst in late 2020, and we're hopefully going to get the keys handed over in October 21 when Joss officially finished their construction, and we begin commissioning the plant, fingers crossed, in late November, with a plant fully operational in late December, early January. So that's a little bit of background, but as I said, it's a really neat joint venture relationship, and it truly represents the circular economy in my view, in that we've got Cleanaway at one end providing us with all of the necessary feedstock that's feeding the plant. We've got PACT Group charged with running the facility, but also one of the offtake partners, but its primary function is to run and manage the facility. And then we've got our friends at Asahi, who will be our major offtake partner, and will be producing primarily carbonated soft drink beverage bottles for Pepsi, which will be using most of the material produced from that facility. So I am going to chop and change a little bit here, so I do apologise in advance if I do confuse people, because I am a PACT employee and sort of talking about the joint venture business at the same time. But a little bit about PACT for those of you who don't know. Publicly listed company, and I think I'm correct in saying that we were listed in 2015, prior to which we were a private business owned by Rafael Jaminda, who is still very heavily involved in the business, but built on acquiring and have been very, very successful at it. And at the current time, we've got 110 operating sites in 15 countries, employing over 6,000 people now, and selling into about 7,000 plus customers. So a very wide offering, and I won't bore you with the detail, but we're in packaging, we're in reuse. I'm heavily involved in the recycling division. So it's a very dynamic and diverse company to work for. But back on our new plant in Albury, and as I said, it really, the joint venture partners is a true reflection of the circular economy. And as I said, I won't repeat the clean away aspect. They have and own and run the New South Wales Container Deposit Scheme at present. And all of that material will be flowing into the Albury facility. In addition to that, they have MRFs operating around the country, which will also supplement in-feed material into the plant. And we will also seek to purchase material as and when required from other parties. Pact Group, its involvement outside of running the plant will really be looking at buying wash flake for its thermoforming business. We have two fairly large operations, one down in Victorian Broadmeadows and another in New Zealand, that will be taking quite a bit of wash flake for its thermoform business. And then of course Asahi, who are situated in Albury, and it was one of the many reasons that we chose Albury as a destination, given that our major offtake partner is a hop, skip and jump from the site. This facility in particular, in focus, total project cost of 58 million. There's about $13 million in building. So we not only funded the capex for the equipment, we also built the plant. And in round numbers, we estimate around 28,000 tonnes of in-feed feedstock of PET flowing through the plant. And we'll be producing primarily two variants of food grade rPET, a low IV material for the non-carbonated soft drink beverage packaging, and a carbonated higher IV resin for carbonated soft drinks. And we're hoping to get around 21,000 tonnes per annum out of the facility. Annual turnover estimated around 36 million, and we'll be running a split rostering operation. The wash sorting plant will run 24/5, and the extrusion operation will run 24/7. As I said, the main reasons for Albury is it effectively services the East Coast for inputs and outputs. It's a competitive cost profile for logistics and operations. And of course, it's close proximity to the Albury bottling facility. The plant itself, for those of you who are interested, two major OEMs involved in the project. We selected Umut, an Italian company, who are providing the wash pre-sorting technology. And we selected Starlinger for the extrusion decom part of the operation. And the Italians were probably quite technical in their offering, and one of the many reasons why we selected them. They looked at the design scope, particularly the bale audit data that we provided them, and gave us a belts and braces approach. So this facility will primarily run natural PET, but equally it will eject, bale and consolidate coloured PET and thermoform trays. And very, very important byproducts for us. The coloured PET will go up to our Narrabri facility to be turned into wash flake, and it will service some of our customers up in the northern region for non-food grade applications. And likewise, the thermoform trays, we are very, very keen to pursue that heavily in order to produce a quality flake out of the thermoform byproduct to go back into our thermoform businesses. In addition to that, we've got a polyolefin module in the plant that will take all the cap and lid, and that will also be sent back to one of the Astron businesses to be converted into a valuable resin. Two things I'd like to call out before we move on is that we have engaged some local IP into this facility. Aerofloat in particular, a Sydney business, and are really growing quite rapidly with their water treatment technology. And we're very keen and proud to have them on board delivering the water treatment part of the business. And there are various other contractors involved in the project, which we hope their IP that they develop in producing this plant for us can be shared for future projects down the track. Just very quickly and very simply, the flow diagram of the plant. As I said, its primary focus is to convert natural PET into natural food grade resin. And we took a very keen interest in all of the optical sorting technology that was available at the time around the world. And TOMRA was a standout in terms of the flexibility, their offering, and also their technology. And in particular, their latest technology, their Sharp Eye technology, which will not only sort our coloured PET out, but it will also sort our tray material, which we're very keen to pursue separately. Back on PACT, and I don't want to repeat myself because the other presenters have sort of circled around this quite often, but like all companies in this space, our vision is to lead the circular economy. That's the very reason we've gotten ourselves involved with Cleanaway, and I'm very thankful that we've done that. And being in the packaging business, we know that this is the future, not only for us as a company, but for us as a society. So we're very keen to continue on with it. A snapshot around the country with what we are doing at present. We've currently got, as I said, the Albury project, and we announced last week a second facility, $38 million facility, joint venture with Cleanaway again to produce a RHDP plant, which will come online towards the end of next year, and that will well and truly immerse us into the world of dairy RHDPE, food grade RHDPE, as well as coloured HD and polypropylene. But you can see there we're currently well off the pace in terms of our aspirational target on tonnes of recycled material. We currently produce out of 14 facilities 35,000 tonnes per annum, and by 2025 we've got a vision of having that tonnage output dramatically increase into 100,000 tonnes out of 20 facilities. So we are putting our money where our mouth is, and we are destined to create a true circular economy for not only us, but for the country. That is it. Steve, it was short, sharp and sweet.
Thank you, Paul. Some really exciting developments coming out of our own PAC group. So we'll open up to the floor now. So I can see there's quite a few questions coming through. Before I get to those, do any of our panel members want to make any comments or start off proceedings with any particular questions to any of our speakers?
Oh no, I think go to the questions, Steve. That's fine.
Okay. All right. So first question in the Q&A box I've got here for Helen. There are fewer companies looking at advanced recycling through pyrolysis in Australia, but struggling with legislation as it generally only categorises this as waste to energy, which comes with a lot of baggage. What do you see as solutions for getting over this hurdle?
Yeah, that's a challenging one. I know that there have been issues in New South Wales and I guess elsewhere. I think it is a challenge for the bureaucrats. I know in New South Wales they were developing a new policy for alternative or advanced technologies, so that things like the Licella technology wouldn't be classified as waste to energy. But I'm not sure how that's going. So I'm not sure what I can add really in terms of a solution. I think just engaging with government as soon as possible to start the process, because I think they have been grappling with this, and government processes just aren't quick. They're very slow. I don't know whether Ed's got any big solutions from his experience in the UK and how they went getting their plant up and running.
You're on mute, Ed. Yeah.
Yeah, sorry about that. Yes. The plant that Licella are building in UK is still not commercial. It's still, there've been no formal announcements except the initiation of the process. I think everyone's hopeful that it will work, and let's hope the Australian technology will make a difference. They're building it in the northern part of UK, where they've got quite a large population, lots of material, and potentially not too far away from petrochemical destinations. So it's promising, which is really quite different from where we are in Australia, where we have very little avenues to actually take materials that we want to turn into, let's say, a liquid hydrocarbon, and then feed that back into a system. If you have a look at our refineries, the refineries are busy making petrol, diesel, and aviation fuel. The Geelong plant does make propylene, which is used then to make polypropylene. And the yield from a pyrolysis oil going into propylene gas has to be looked at, because at the moment we're putting minuscule amounts into the process. So we're not seeing the composition variation changing very much. But when you undergo pyrolysis, you're randomly cutting the hydrocarbon chain up, and unless you've got a hydrogenation process working, you'll produce carbonaceous or heavy oils, and they will then contaminate what is a relatively straightforward stream. So at fractions of a percent, there's no problem. But if you got to 10% or 20%, then we'd have to see some new things. In some evaluations that we're seeing in Germany, where they have question marks over high rates of addition of pyrolysis oils into refineries. So it's still to be seen. And their judgment is that this area is still under development. So if it's still under development, how far are we from real life applications? We'd have to say it's probably 10 years. So, but we need to do more. We need to do lots of things within the next 10 years. And well done, Paul, for showing us that great plan. I stood at that site when it was just a fence around a block of land. Great to see all those buildings up on there now. Well done.
Thanks, Ed.
Thank you, Ed. Another question here around bioplastics, which they tend to hold promise to replace existing petroleum-based plastics in the market. If so, how long does it take? I'm just trying to, so whether bioplastics hold promise. So it's, the question's around bioplastics and whether they can take up a portion of the market in Australia. Ed or Helen, what's your view on that?
Well, I'll just start quickly. It's still a very small market in Australia. The latest data we have is it's around 2,000 tonnes of bioplastics on the market. And, hearing from people at the Australasian Bioplastics Association, they talk about this being staying a relatively small part of the market, that really globally, we're still seeing only small volumes. They want to see it going into higher value applications, not just, cutlery and plates, but there's definitely a place for it. And I know there are new plants being built. There's a huge amount of demand for it. I guess my point of view, I love the idea of bioplastics. We just need to make sure that they can be recovered at end of life. Ed mentioned PLA being really a contaminant at the moment. And I guess it's a case of scale. And once we get to a certain minimum volume, it would be worthwhile potentially for a MRF to separate them. But at the moment, I think we're arguing bioplastics need to be either recyclable or compostable.
I agree. And, the other issue with bioplastics or biopolymers for that matter is the potential for them to end up in the recycling stream, but also the issue with the compostability, because as we know, the home compostability and industrial compostability is quite different. So, and we've also heard that there needs to be, industrial composting facilities developed in Australia as well for a lot of these materials. So, look, they do have a role to play, but it needs to be, a niche in certain niche applications. So, yeah, it's sorry about that. So yeah, it's certainly an area that's we'll be watching with a close eye. So
if I can make a quick comment on bioplastics, the problem is, where do they go?
Yeah.
They're not going to go into the home compost. If you put them to the recycling stream at the recycling plant, they'll go into the mixed plastics at the end, which we can't export anymore. So what happens in the plastics plant? They're not going to be identified or recycled. So they're going to take the place of a plastic part that could be recycled. So all that work in making these bioplastics that we're putting on is really going nowhere. In Europe, they're all ending in the incinerator. So if you make a bioplastic in Europe, it goes waste to energy. And so we're putting lots of effort. If I go to a cafe and have a look at what they're offering their customers, they're offering them cardboard, which is possibly made waterproof with PFAs. We don't know. And that's going to be the next crisis for the paper industry. But then they're using PLA for their transparent containers, whereas they could use a thermoform PET cup, which does have a recycling destination. So we don't have industrial composting. We can't have home composting. So why are we going there? And this is something the plastics industry really needs to grasp. Why aren't we seeing leadership from Chemistry Australia in this area to come up and put some guidelines out there about what works and what doesn't work? We actually know what it is. We shouldn't be scared to state the scientifically obvious. And I see so much research in universities in Australia and globally trying to make everything compostable. So what does that mean? We're not going to recycle? Are we going to compost everything? I'd love to see people putting all of their plastics in their backyard and waiting for them to compost in a year, because it's just not going to work. And we need to have this realism coming through to the universities and to CSIRO, which is not researching circular economy that I can see. Chemistry in Australia is just looking after the granules that spill on the floor in Operation Clean Sweep. Very important program, but I just call that housekeeping. So let's really get serious about the circular economy and putting innovation and effort where it has to go, not based on consumer preferences. So I think bioplastics need to stay small.
Can I just make a quick comment, Steve? For those who are interested, APCO put out a publication just recently with ABA and the Organics Recycling Association called Considerations for Compostable Packaging, which really is trying to provide that sort of guidance to brands and packaging companies. And there's some decision trees in there, and it definitely favours material recycling, or if they're going compostable, to be certified and to make sure there's a recovery system in place. So it's a good resource if anyone's interested in that area.
Thank you, Helen, and thanks for the commentary from Ed. Thank you. Another question here: what are the opportunities for small-scale plastic recycling? Is there any government subsidy available?
Yes. Short answer is that obviously scale is one aspect of any sort of government grant, but I know Mike Ritchie's on the call tonight, and his company, there's a plug for you, Mike, MRA. He'd be most happy to talk more specifically, but yeah, I mean, there are a number of different grant funding streams available in the respective jurisdictions, and if you think you've got a good story and your business case can be supported financially, I see no reason why you apply for 10 million or you apply for tens of thousands.
Thanks, Paul.
Steve, I'll just chip in while you're looking for a next question. Ed, you mentioned that in Europe they're starting to apply taxes to companies now that are not using any recyclable content in their packaging. What's your view on how that's working, and will it make its way to Australia, or should it? What's your just your comments, please.
So in United Kingdom, there will be a £200 per tonne tax on packaging that doesn't have 30% recycled content in it. So for single-use plastics. In Europe, they've got what they're calling a state charge on a country of €800 per tonne on packaging that doesn't have 30% recycled content. So what's happening over there is huge demand for high quality recycled plastics material. Brand owners are working with recyclers. They're signing 7-year contracts for the supply of recycled plastics to put back into their packaging. There is an absolute scramble for capacity. Companies are announcing new capacity in film, high density polyethylene and polypropylene recycling, and especially PET recycling. Everyone is heading for the circular economy. Will it come to Australia? If we're serious, it should come to Australia, because I can tell you it's not going to happen voluntarily. I've watched Australian progress in the area of recycling over the many years, from when I was in Visi, going further out into the UK. And we're constantly running studies and feasibility, this and that. And I just see companies not taking the step. Now, if we put forward a tax, a company can avoid the tax. And the purpose of a tax is for it to be avoided. It's a stimulus for action. So when you have a date, then what will happen is people will work towards getting their supply of recycled material. That then encourages the recyclers to invest. That encourages the collection of material. It pulls the whole thing through. Now, if we don't have it, we won't get there. It's as simple as that. I don't think the business world, especially the big companies, the chemical industry, the importers of plastics, have got the self-interest to do it. They're not going to do it. So just like we've had the government ban exports, it stimulated investment in the recycling industry. The packaging industry needs a packaging tax to get them moving, to make the changes, to pull the supply of materials all the way through. It's happening in Europe. If we want it to happen here, we have to do the same thing. It's not rocket science. It's just fiscal measures by the Treasurer, and he'll be the best environmentalist when he does it.
Thank you, Ed. Another question in the chat box. The key reason we landfill so much plastic in Australia is that the economics are still broken. 1 million tonnes being landfilled is rational. So how can we quickly change the economics? Landfill levies, producer responsibility funding, or regulation? Who would like to answer that?
Gee, that sounds like it's come from Mike Ritchie. Look, I think there does need to be some sort of intervention, and it's going to be interesting to see what form it takes. I think this government has shown a little bit more willingness to intervene than in previous years. I mean, by banning exports, that was a pretty courageous move to stand up and say they were going to do that without knowing for sure that we'd have the capacity to reprocess it all in Australia, although we seem to be heading in that direction. So I think there is some work that needs to be done, and there will need to be more interventions. I think we're going to get a fair way by, ramping up the voluntary measures like the voluntary targets, which is certainly, I've seen so much more action in the last couple of years compared to previous decades, really. But I agree. I don't know what the answer is, whether it's a tax like the UK, whether it's regulated EPR, whether it's regulating the targets. I guess there's all sorts of options that need to be on the table.
Thanks, Helen.
Quick one from me. I think it's really quite clear. Obviously, it's too easy to landfill. If we're collecting material and we had landfill levies which were higher, then the recycling operators would, first of all, charge the councils far more for the collection, because they'll be commenting that we have to landfill all this at very high cost. So council will have a much poorer deal from the collection process. And then everyone will be interested to scramble through what the consumers are putting into their waste, and how much waste goes to landfill. I watch picnic spots where I hear all the glass bottles going into the bin. You know, you can see that we're not very good as a nation in recovering what's recoverable. You know, take the example of the glass bottles, where they've boosted the recycled content. That's coming out of what's being collected. Now, we have our hands on post-consumer landfill resource material. I won't call it waste. Heaven help us if we have a CRC for waste. We should be growing circular economy. But let's take the material and unscramble it and take out the recoverable materials. We're already past the day in the year where we're using resources of the planet. So the best thing to do is to raise the landfill levies. The economics will solve the rest of it, because people will invest and recover and will reduce the amount of waste. That's what they've done in Europe. It's simple and it works. I don't know why we have to learn it the hard way.
Professor Cozier, there is a CRC for plastic waste being developed.
Let's not call it the plastic waste CRC, for goodness sake. Let's set the target. Let's call it a circular economy plastic CRC rather than one targeting growing plastic waste. We know how to grow plastic waste. We're trying to create a circular economy, for goodness sake. Let's get that right.
There's quite a few more questions in the chat box, but just a couple from me, guys. Helen, maybe for you, what do you think the impact from COVID is going to be, particularly around you know, meeting those targets?
Yeah, that's a really, really interesting question. We've got the raw data in from 2019-20, and we're still trying to work out what's a trend and what's just a bit of data noise. It does look like there's more cardboard, and particularly business to consumer, so online shopping. No surprise there. That's been one of the COVID impacts, accelerating a longer term trend. It does look like there's more plastics, you know, for like food service, which is no surprise, even though that year only picked up a few months of COVID. So it's going to be very interesting to see how the economic impact of COVID is weighing up against increasing use of packaging for takeaway food and online shopping, and whether any of those changes are long term. Clearly, you know, we've shifted away from reusable coffee cups and reusable food service packaging. Let's hope we can go back there. But yeah, I think that's one of the big questions at the moment. Don't know the answer.
And thank you. Professor Cozier, what do you say to the Canadian government, which recently passed a bill to label plastics as toxic?
Well, it's clearly wrong, you know, because unfortunately, I'm not sure. I haven't heard of that before. I have seen, for example, in the United States, a call to label polypropylene as not recyclable. Now, it's clearly recyclable, but if it's not being selected by MRFs, then it's not being recycled. And the definition of recyclable is that it's being recycled. So, but the issue of calling plastics toxic is clearly misguided. I can't understand why they would do that. Unfortunately, the media propagates lots of stories that are simply scientifically untrue. And so we really need to knock some of these things on the head. And now someone should, I'm sure the chemistry in the US, I think, no, they call themselves plastics now, would have said something. But a lot of the industry associations have not served themselves or their members very well, because they've been out of the action. They've been inarticulate about these issues. They've looked to, you know, stand behind their businesses as opposed to taking a holistic view of the environment and stating the facts as they should be. And so then they become less credible in the public forums. But clearly that comment just sounds completely unsubstantiated as far as I could tell, because clearly they're used so widely in food packaging for so many decades that they're clearly not, that's not the case. If there's something specific, then we probably have to listen to what those arguments are. And we've got enough scientists in the world to guide us to do this as well. So politicians should take heed of our scientists, as hopefully they will do that.
Thank you. Right, just further questions here. This one might be for you, Helen. So did the LDPE reprocessors give any indication of what they are going to be producing from the LDPE waste plastics?
That's a short answer. No, we didn't ask them. It was more asking them about capacity and planned expansions. So we didn't talk about where it was going.
Okay. And what is the percentage of bioplastics currently on the Australian market?
Well, the latest data was about 2,000 tonnes out of about 1 million tonnes, so tiny.
Very tiny, yeah.
It'll be growing, but at from a very low base.
Okay, there's another good question here, maybe for you, Professor Cozier. Why is there no distinction between oxo-degradable and oxo-biodegradable, which has been the subject of a legal challenge to the EU regulators?
Possibly because there is no distinction between the two. If something is oxo-degradable, it means they've added pro-oxidants to the material, which initiate oxidation. Now, the claim there is that somehow the initiated oxidation process at some point makes the material biodegradable. Now, I've looked at the studies and it's really hard to see validated data that when you say degrade polyethylene and it reduces the molecular weight, you end up with waxy materials. These materials are incredibly inert and biological systems and bacteria can't digest polyethylene or wax. So we're certainly not very good at doing it. So I would say that there's possibly no distinction. And if they're oxo additives and they get into the recycling stream, I know that the companies that make the underlay for concrete slabs are worried about getting that material in because they're saying, we want our buildings to last for hundreds of years. We want the membrane to be impermeable for hundreds of years. We don't want that material in the recycling stream. And the companies that make underlay make it almost exclusively from recycled materials. Now, I've also heard that companies are putting these additives saying well, these additives will make the plastics in landfills degrade. Well, if plastics are in landfills, let them be there. They're sitting there as carbon sinks.
Correct.
Why should we degrade these materials and liberate who knows what? I don't think they do much other than undergo chain fission. So it seems that they seem to be pointless additives, and I would say they're pandering to the sort of consumer appeal that they think these additives might have. They're not contributing to the recycling industry. They're not contributing to the environment. They possibly are a source of microplastics, and they really should be banned as they have been banned in Europe. And yet, if you go to your local store in New South Wales, you'll see them everywhere. And they should be on the list of single-use plastics that need to be banned, and they need to be banned very quickly.
Yeah, look, I think they have been added to a lot of the jurisdictions around Australia. They have been included in the bills, particularly in South Australia, I think WA and others who are following suit. So, yeah. There's a long sort of comment question here. Regional collection and aggregation logistics make circular outcomes for many plastics quite expensive in Australia, given the size of the country and the volumes used. With so many product stewardship schemes being investigated and potentially coming on board in the next couple of years, it would be great to develop cooperative collection aggregation models to drive cost efficiencies. That's a comment more than a question.
Well, I think that makes a lot of sense. We've got major capital cities and we've got regional centres, and regional aggregation makes so much sense, especially if you have MRFs in those areas and they can then feed recycling plants within the big urban population centres. It just makes so much sense. We need far more sorting capability, which we're lacking at the moment because we're simply taking a bin and putting it into landfill. But if we sort it, we have a resource, we can recycle it. So it makes good sense. It's a good comment.
Just before I go to the next one, does AI have a role to play, particularly on the MRF side? Helen, I saw in one of your earlier presentations one of the slides, you mentioned something about opaque PET, which is currently not being recycled. Could something as could AI have a role to play for a material or product like opaque PET?
I assume so, but I think I might throw to Ed for that one. This is more his area than mine, with all his work in sorting technologies.
Well, no, you can recycle opaque PET. You can pick it out as well. The conventional sorting machines do that. In a way, we're using artificial intelligence in those sorting centres right now. What we're using is near-infrared. It identifies the polymer and the colour. So we use near-infrared and optical at the same time. So we can separate them. And I think the commentary that coloured or opaque PET is not recyclable comes from the fact that we don't know what to do with it once it's separated. Plus, ask the PET plant operators, and Paul will find this out very soon, their number one enemy will be white PET because it induces haze in the finished product. So the companies that put opaque PET on the market need to ask, well, what is going to happen to this? Now, if you do have big volumes, you can separate it out and you can put it into a separate stream. So it can be recycled, totally recyclable. It's just that it's seen as a contaminant in the clear material. So in an ideal world, you would have uncolored material. In Japan, there are no colored bottles, let alone opaque. And there is no law. The industry has got together and said, we're not going to color our bottles. All bottles in Japan are clear. Their recycling rate of PET is 90% right now. They're aiming for 100%, right? I know it's Japan, but that's an industry association making an agreement. They have the will to make a difference. They're not indifferent about what they're doing. And so surely we can adopt this. That's just an adoption. That's just changing your position about what you make and thinking about the future. This is not rocket science. This is just common sense and simple environmentalism, doing something that will actually be recyclable as opposed to something that's difficult to recycle.
Yeah, couldn't agree with you more. Another AI question here. Why not have small and smart high-tech plastic sorting machines and grinding machines in local councils, which could be managed by small businesses? I'm not sure. Why not have small? Yeah.
Just quickly, and I didn't answer the question on AI, on robots and so on. AI is coming for big installations, but a robotic system is very expensive to install. And for example, a near-infrared sorting machine will cost anywhere of the order of 300,000, and you have to have ancillaries with it. You're very quickly talking about millions of material. The best thing is to move these materials to MRF, which is equipped with all the facilities. The MRFs can do the sorting either very simply with optical systems, and the mechanical systems are coming, and they will take the place of people on these lines. And artificial intelligence will actually help us discriminate between food and non-food packaging because they are getting clever. But this involves machine vision. Machine vision is expensive. It's computationally very intense. So you need very powerful supercomputers to run the machine vision system. And then you have to have very rapid pickup and ejection systems. So we're not there yet, but it is coming, and it'll probably happen within the next 5 years. So we'll see AI introduced, but these are expensive. And so that means you have to have operations at big scale to make it effective. At the council level, we can have people. Let's have all of our people who want to do something to contribute to the environment on a sorting line with a conveyor belt. Really simple. They do it in Asia all the time. So we can do it here as well, if we dare try and do it. If we want to make a difference, we can get on a belt and hand sort, but not many people like that sort of job. But it can be done.
Fantastic, thank you. Look, in the interest of time, I think we'll wrap it up there. thank you to all our three speakers this evening, Helen, Professor Cozier and Paul. Thank you for contributing to this last session in the circular economy. Thank you as well to our organisers, the SCI, RACI and SPE, and our sponsors. It's been a wonderful series. At this point, I might hand over to my colleague Yvonne, if she could say a few words on our behalf.
Thanks, Steve. Thank you for such an engaging webinar this evening. Professor Cozier, Professor Lewis and Paul. I just wanted to say a few words. First of all, what an amazing series we've had. On behalf of our organising committee of this series, thank you to all for being part of this journey, a journey looking into a sustainable future with plastics in our Australian economy. And thank you to all the outstanding speakers who have been in the series. We started at the beginning of this year with cutting edge innovations, then the big challenge in human behaviour, which Professor Cozier was talking about. Maybe we should do sorting in our council areas, through to a new future, dealing with litter, sustainable solutions, challenges in packaging, and finishing with the roadmap to a sustainable and circular economy. So I think that our last episode really polishes everything up, and thank you so much for these outstanding presentations tonight. A special thank you to our sponsors, Reckitt Benckiser, BASF, Qenos and Foundry IP. They made this series even more special for us. It's been a much privilege working with the organising committee. And if those of you who may not know, they are Gary Bowman, who's the president of the Industrial Chemistry Division in the Royal Australian Chemical Institute. And then there's also Han Michel, who's the president of the Society of Plastics Engineers, Australia, New Zealand. Dr. Richard Tweets, president of the Society of Chemical Industries. Jenny Sharwood from the Royal Australian Chemical Institute Education Committee for Victoria, and also Dr. Steve Petanakis of the Society of Plastics Engineers here, and also working for PACT. But I wanted to make a special mention to Han. So for the many years that I attended all the Society of Plastic Engineers events, just your spirit and passion created the awareness, to create the awareness about the positive impacts of plastics and how we need to manage plastics litter. It was just contagious. So here we are with this series. Plastics is a precious resource, and I hope everyone in this journey during this series takes that away as a memento, and also start to spread this word. There's so much value that plastics brings us, as we have seen in the episode this evening, and also in all the series. As we have experienced with all the medical equipment during the pandemic time. So if you look around, everywhere was using plastics. So a lot of chemistries went into those plastics for their compliance to meet all the medical criteria, etc. So I hope this message from the series reaches everyone, and thank you very much.
Thank you. Thanks, Yvonne. Thank you, everyone.
Yvonne, all the credit goes to you. Fantastic job this year. Thank you.
Oh,
Yeah, thanks, Yvonne.
Oh, we did it all together. I loved it.
Yeah.
Thank you.
Thanks a lot.
Good. Okay.
Thanks, guys. Good night.
Thank you.
Good night.
Thank you.
Bye.
Good night.
Thank you.
Bye. Bye.
Well done.
Bye.
Good night.